Minnesota has plenty of rocks and minerals, but when you start to learn about rocks, it's important to remember that they just fall into three main categories. That's igneous, sedimentary, and metamorphic. In Minnesota, we have igneous rocks like granite and basalt, and these rocks were created through lava that cooled or magma from the Earth's crust. Sedimentary rocks like sandstone and limestone were created by sediments that were worn from wind or water and were compacted down together. Metamorphic rocks like gneiss or quartzite have been created through extreme heat and pressure. So metamorphic rocks actually used to be an igneous or sedimentary rock, and through that extreme pressure, the rocks were turned into a brand new type of rock, much like a caterpillar turns into a butterfly through metamorphosis. So now that you know a little bit more about the three main rock types, let's go check out some rock ID tips.
You might want to take a closer look at your rock in question or a favorite rock from your collection to observe some more properties or characteristics of your rock that can help you determine what type of rock it might be exactly. Some of those properties are color. What's the overall color of the rock? Does it have more than one color? Does it have shades or bands or patterns of color in it? You also want to look at texture. Is it a smooth rock all the way around? Or is it kind of a rough rock that feels kind of sandpapery or kind of gritty on your fingers? How does it feel for what we call the grains or some other minerals that are embedded within the rock that stand out? Are they really, really big and easy to see that there are other parts to your rock, or are they very tiny and it's really hard to tell and your rock looks pretty uniform and smooth all the way across? What's the size and the shape of your rock? Is it jagged? Is it smooth or round all the way around? How big is it? Does it fit in your hand? Does it fit in your pockets? Is it a rock you found out in your yard and you're not going to be able to move it? And then the last thing is luster. Is it shiny or is it dull? So those are some observations you might want to make on your rock. And oftentimes, sketching a picture of your rock can help you make some of those observations a little bit easier. So I'm going to do a quick little sketch of one of my favorite rocks from my collection here. So my rock is kind of gray and green. It's jagged. I think it kind of looks like the state of Minnesota. Fits in my hand. And it's kind of rough. So that's my little sketch of my rock.
Let's try a science experiment. All you need is a collection of minerals that you might have in your rock collection, a penny, a piece of glass. Please don't use a window. Make sure to ask your parents for maybe a bottle or pasta jar that you might be recycling, a nail, and then a piece of sandpaper or an emery board. So what are you studying, you might ask? We are going to be looking at Mohs hardness scale. And this scale was invented in 1812 by Frederick Moh in Germany. He was a mineralogist, and he wanted to figure out how to rank his minerals from the softest type of mineral to the hardest mineral as one way to categorize them in his work. So 1 is the softest type of mineral, 10 being the hardest, which is a diamond. Today we have a range of minerals starting with quartz. So the first thing you do on your hardness scale test is just run your fingernail on the mineral to see does anything come off. In this case, no. My fingernail is actually the thing that is rubbing off. So this piece of quartz is definitely stronger than my fingernail. Next, move to your penny. Do the same thing. Can you rub off any piece of the rock, or the mineral? Same thing, no dice. Have to move on to the glass. In this case, I'm trying to see if, it's kind of hard to see here, but the glass actually got scratched by the quartz. So I know that the quartz is stronger than the glass. Again, this is a really hard mineral, so this nail is also not even scratching the surface. Finally, when I go to my emery board, you can see it made a mark. And so this tells me that it's slightly less strong than the sandpaper emery board, meaning that it's in a range of 8 to 9 on the hardness scale. So that means it's a pretty hard mineral. Talc is our final mineral. Now talc, we're going to start off again with our fingernail test. My fingernails are a little tired from all this testing, but you can see that I have pulled some of the powder off onto my fingernail, which means that talc is softer than my fingernail, putting it at a range of about 1 or 2 on the hardness scale. So go through your mineral collection and test out using Mohs hardness scale and see what you find. Have fun! They're small, sharp, or round. Each rock you see has a tale to tell about how the land around it has been shaped for millions or even billions of years. If you look closely, rocks can tell you the stories of oceans and volcanoes, great sheets of ice, and gushing rivers, all right here in what we know as Minnesota. So join us as we tell a rock story that highlights some common Minnesota rocks and where to find them. We'll start with Minnesota's state rock. Do you know it? It's the agate. Agates are beautiful striped rocks that were formed when water fell into the holes of basalt, and as the water evaporated, layers of silica formed, creating the agate. These can be found along the shore of Lake Superior, but you can actually find agates throughout the entire state of Minnesota because glaciers pushed down from north to south, spreading the agates all throughout the state. Over 1 billion years ago, lava actually flowed up through cracks in the ground, creating pockets of basalt. And these were formed all along the shores of Lake Superior as well. Isn't it crazy to imagine there being lava all over Lake Superior? But that's what created the basalt. Gabbro is another northern Minnesota rock. It can be found on the cliff faces in Duluth. And the word gabbro got its name from the Latin word smooth. Moving into the interior of Minnesota, we find the old mountain ranges where iron can be found, as well as taconite, which has smaller amounts of iron, formed over 2.7 billion years ago and are what later became known as the Vermilion Iron Range. So here we have a piece of iron and a piece of taconite, both of which are used in steel production. Granite typically formed as large bodies of molten rock rose beneath mountains in central Minnesota over 1 billion years ago. Do you see a common pattern? A lot of this happened over 1 billion years ago. Granite comes in lots of different colors, including white and pink to gray and black, and that depends on the mineral content that it contains. While many of the rocks in northern Minnesota were created from hot lava and magma flows, down in southern Minnesota, rocks like sandstone were created through rivers and moving water. So they carried the sand from the sea that had covered Minnesota many years ago. And as this water reached the sea, it stopped flowing. Grains of sand settled to the sea floor. Over time, chemicals in the water cemented the grains together to form sandstone, which can be found in the Twin Cities area, so not far from where we live. Limestone was formed also over 500 million years ago from a combination of calcium carbonate and seashells at the bottom of the ancient seas. Limestones in some places contain plant and animal fossils. At Forestville or Mystery Cave State Park, you can see steep bluffs of limestone and even tour the limestone caves. As ancient rivers meandered, they deposited sand along their banks. Eventually, the grains of sand cemented together into sandstone, much like what happened over in the eastern side of Minnesota. But as the Earth's crush pushed the sandstone underground, immense heat and pressure turned the sandstone into quartzite, which can now be found in southern Minnesota on the western side of the state. You can see famous cliffs of this pinkish-purple quartzite at Blue Mound State Park. Our final Minnesota rock is the oldest rock in the world, gneiss, found in the Minnesota River Valley. Morton gneiss, which is almost 3.6 billion years old, is a metamorphic rock. Gneiss is quarried for use as a building stone and for monuments. You can find outcrops of gneiss near Morton, where they have the famous Rainbow Gneiss, Redwood Falls, Sacred Heart, and Ortonville. Now that we know a little bit more about Minnesota's rocks, and we know the story of how the rocks came to be in Minnesota as the landscape changed over billions and billions of years, we're going to talk about how you can create your own rock collection and to start looking for rocks throughout the state of Minnesota.
Starting a rock collection. The first thing you want to do before going out and starting to collect rocks is to always make sure that it is safe where you're going to go collecting, and also that you have permission to go collect rocks on that piece of land. Just always check with the agency before you do so to make sure that it's legal to collect rocks where you're going. In Minnesota, for state parks and scientific and natural areas, as well as a lot of county and regional parks, it is not legal to collect rocks in those places so that they can stay there for everyone to enjoy. So always double check and make sure that that is a good place to go. So to house your rock collection, you can keep them in a box, you can keep them on some shelves, you can get little cases for them, all that kind of stuff. But every time that you get a rock and you want to add it to your collection, it's always a good idea to write down some information about that rock. First thing you want to do is check on the location and write down where you found the rock, because that can help you out with identifying what kind of rock it might be. It might also make it a more valuable rock to your collection because that's a rare rock for that area. So writing down where you found it is a good idea. Also, when you found it, what date you found it is good information to collect on it. And then you can put down whatever other information you want, perhaps where you were looking. All the rocks can be grouped together that you found on that day. If you want to add notes about the weather, that kind of stuff. So the more information you have, the better. Now, some of the rocks in my collection are so unique that I remember exactly where and when I found them or was gifted them. And so I don't have any identifying numbers on them. However, some rocks are rather nondescript and look a lot like a bunch of other rocks that I have in my collection. And because I didn't write down any information about this rock, I don't really know exactly where I got it or when I got it. It's a cool rock. It's one of my favorites. It fits nicely in my hand, in my pocket. But all I know is that I got it on the North Shore of Lake Superior and that it's some basalt. Other than that, I don't know anything about it. Here's another rock. This is a piece of sandstone, but again, pretty nondescript rock. It could look like anything that you find on a gravel road, but this one is labeled with a number that corresponds to a card with some data written down on it, so I have that information about that rock. So hopefully you learned some cool stuff about rocks and some ideas on how to get started with your collection. So enjoy your Minnesota Rocks and Minerals.